Okay. Taylor?
You said 10.4?
Nope.
I don't remember what you said. 10.5.
Oh. Okay. .5, we're doing the fundamental principle of counting. All right. Write it down. I really only have like 1 page of notes. I could stretch it to 2. We could do several examples and everything. I still don't see us getting everything out of the way. All right, fundamental principle of counting. There's 2 ways of doing this, okay? And I'm going to show you one way. It's called a tree diagram. It is used to find all possible outcomes. Okay. Let's say you're given what's the possibility of first digit being 1, 3, or 5, and the possibility of second digit being 0, 2, or 4. So how many total outcomes can we have if, it's kind of like rolling the dice sort of thing. And let's say if we had like a spinner and we're looking for 2-digit numbers, and the first digit can be 1, 3, or 5, and the second digit can be 0, 2, or 4. How many possible outcomes can there be? It could be 1 and 0, 1 and 2, 1 and 4, 3 and 0, 3 and 2, 3, and etc. Okay? So you can sit there and count all that up. But the tree diagram looks like this. Now, again, this is one possible way of figuring this out. This is also with very limited information. This is very basic. There's going to be way more outcomes for bigger problems, bigger situations. Let's say first digit. This is the column for the first digit. We have 1, 3, and 5. Those are the possible first digits, 1, 3, and 5. Right? And then for the second digit, we have 1 can be with 0, it can be with 2, it can be with 4. 3, can be 0, 2, and 4. 5 can be 0, 2, and 4. So those are all the possibilities. And the results would be we could have a 10. See, 1 and 0 is 10. 12, 14. Here we could have 30, 32, 34. And then here we could have 50, 52, and 54. Those are all the possibilities. So how many total possibilities are there?
9.
Very good. There's 9 total outcomes. I'll let y'all catch up and then you can ask questions. So that's the tree diagram because of this right here. I don't know. That's just what they call it.
Is it because the branches out?
I guess so. Are there any questions about this? So we're looking at all the possible outcomes. We listed the first digit and the possible second digits or combinations. And we have 9 total outcomes. Any questions? You have one? All right. Now, we went to, when you're done, put your pencil down so I know that you're done. All right. But I don't have to draw this tree out if I don't want to. How many choices did you have up here?
3.
3 digits. How many choices did I have right here?
3.
3 times 3 is what?
9.
Or we could do that.
That's so much easier.
That's funny.
Now, there's going to be times in your book that they say draw out the tree diagram. That's a lot of things here. You know?
We won't do it.
I think I'm gonna, make y'all do that. Okay, let me give you another example. Does everyone have this down?
Yes, ma'am.
For example, as to why the tree diagram would be crazy. Let's say we go to, what is that ice cream place?
Menchie's.
No, is it
Are you
Menchie's?
talking about frozen yogurt?
Yeah.
Are you talking about the thing that's right over there?
There's Menchie's. There's.
Isn't it Menchie's where you get all the
Yogurt.
choices and stuff like that?
That's where I bought 3 large
Right?
drinks on the field.
Okay,
And
so-
drink one.
No. We're talking about Menchie's right here.
Yeah, where I bought 2.
No, we're talking about Menchie's. Okay, so if you go to Taylor, and I'm recording this, I asked for the frozen yogurt place. It was answered, right? Then you stop talking. I'm in charge of the class. I have the floor. Got it? Thank you. Okay. If we go to Menchie's, raise your hand if you've been to Menchie's to get frozen yogurt. Okay, good. Then everyone knows. If you go, the first station, what do you get to choose? All right, what you put your ice or frozen yogurt into, correct? So you can either, what are your choices when you raise your hand if you know the choices of, like, Emily, what do you get? What are your choices?
Big or really big?
Cup, that's it?
Uh-huh. It's
Big
like
or
medium
really big?
large. Yes, so like a large or an extra large.
Okay, cup, right?
Yes.
Large cup, extra large cup. Is that the only choices you have of what to put your ice cream in?
Medium, small.
They don't have that.
How about waffle cones?
No, that's not a cup.
They used to have waffle cones though, right?
I don't think so.
Okay, yeah, they did because I've gotten them.
I don't remember.
Okay, the waffle bowls, you know what I'm talking about?
It's in the same size cup.
No, but it costs more. So you can get a large cup. In fact, I'm going to write that on the next line. Extra large cup, because I've gone and I've gotten just the cup, and I've also gotten the waffle cone. Y'all haven't been there in a while, have you? What are the choices of the waffle bowl things? Have y'all seen them or the cones? Huh?
There's a plain one, chocolate ones.
Okay, so plain waffle. And then she said there's a chocolate waffle. Whoops. Okay, so then you go to the next station. That's your flavors. How many flavors are there?
Too many.
Wait, I
Big
can
fries.
do this. No, I can do this.
What?
I'm counting.
There's like 10.
Hold on. It's like 3 per machine.
Two. The middle one's
The
mixed.
middle one's mixed, but that's a choice.
Okay.
So 3 per machine.
A lot.
Like
I was
15.
trying to think.
I think
How
there's
many machines are there? About 5?
I think there's
I would
5
guess
machines.
22.
Okay.
I'll guess around 20. Multiples of 3 with.
Okay, think of machines. Okay, let's go with Emily. There's 3 choice of flavors per machine. You get like either chocolate or vanilla, and then the mixed in the middle, right? And then you get all those others. So there's 3 choices per machine. If there's 5 machines, it'd be 15 choices. So here, this is the frozen yogurt flavors. I'm gonna put flavors here. And if there's 15, here we'd be doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Same thing here, right? That would be a lot to do, right?
Yeah.
Instead, how many choices did we have here?
4.
4. There's 15 flavors as choices. And then the third choice, what do you do after you get your frozen yogurt?
Toppings.
Toppings.
Okay.
Approximately how many toppings do you think there are?
Like
72.
Oh my gosh. Like 40.
Okay, let's go with 40.
Oh, 15.
Okay, can you imagine how your tree would look by now?
Let me check.
Horrible.
Like large cup strawberry M&Ms, large cup vanilla M&Ms. I mean, we would be here all day long. But instead, we can just multiply 4 times 15 times 40. And for the sake of time, I'm going to do it on my trusty calculator right here. 2,400. So in this case, there are 2,400 possible choices.
Time to go get all of those.
Wouldn't that be a fun field trip?
Yes.
Didn't
We just
go
get
there before?
everything.
Long time ago.
That was
Smoothie King.
Well,
Yeah,
no,
Smoothie
once
King.
we all walked, well, I don't know. I know my class walked to Menchie's once, and that was a few years ago.
Which that was us.
Was it y'all?
We never went to
Yeah,
Menchie's.
12 years ago. Last year was our first.
Actually, it's twice. Once we walked there, and then they decided crossing 518, you know, the intersection was a little too dangerous. So then the next time we drove people there. This was Miss Luna's great idea.
I guess
And
I
unfortunately, she had parents volunteer to drive kids back and forth. Not me. I had a teacher at there and teacher here, and I was shuttling kids back and forth, back and forth, back and forth, back and forth.
like
It was
space
terrible.
shuttle.
So anyway, but yes, we've also walked to Smoothie King. We've walked to Marble Slab. Anyway, so there's your possible choices. Do we understand the fundamental principle of counting now?
Yeah.
Let's do another one.
Well, why is it so fundamental?
Oh, it just is. For example,
Funny.
let's say in your closet you have 5 shirts, 2 pairs of pants, and 3 ties. Now that you probably have more than that. Let's say you're going on a trip and you took 5 shirts, 2 pants, and 3 ties. How many total possible outcomes or outfits could you have?
Do we have to?
Emily? Very good. She's correct. 5 times 2 times 3 is 30. So you have 30 choices or possible outcomes, whichever. Very good. So like example, that's what some of y'all probably do already or you're starting to. I know Allie does it all the time when at the beginning of the school year. She, we go to the store and she gets all her different pants and then she's got all the different shirts and we'll even literally talk about how many total outfits really could you have. Same with me. I'll go buy like black work pants, blue work pants, stuff like that, and I'll have maybe 4 or 5 pairs of work pants total. But then I'll buy all these different tops. So then you start calculating how many actual outfits do you have, like combinations. Well, I could wear this shirt with these pants, and this shirt can go over here with these pants. Or it could go over here with these pants, and this could go here. So you start mixing it up, sort of thing. So you don't really have 5 outfits. You end up with something like 30 different combinations of outfits. You see how that works? You don't have to buy 30 total outfits. Yes, Taylor.
So,
Do you have a question about this?
yeah.
Okay.
I'm saying, would they really wear a tie every day?
Taylor, that's not a question about this. Okay? All right, so let's go ahead and open up your book to page 422. Examples, 422. So we'll see how far we get as far as examples. If we get them all done, then tomorrow you're just going to come in and start working. Or we may have to finish examples tomorrow. We're going to start with number 2. Let me make sure everyone's got their book open. All right, Gabby, you want to read the directions?
Make 3 diagrams to follow and find the number of possible outcomes.
Guess what? I'm not going to make y'all make a tree diagram. I just want you to find the answers to these, okay? So, Gabby, go ahead and read number 2.
There are 3 candidates running for mayor and 5 running for a vacant county council seat. How many different ways can these seats be filled?
Okay, so the first choice is mayor. How many do we have for mayor, Gabby? How many choices? 3. And then how many do we have for the city council seat? 5 choices. So, Gabby, how many different ways can we fill these seats? 3 times 5 is 15. She is correct. See, this stuff isn't too bad, is it? That's right. Now, they are going to get trickier. Let's look at number 4. It's not trickier, but let's just do a few of these, get some under our belt. Let's see, wit. You want to read that one?
Sure. There's an apple, cherry, blueberry, and peach pie to choose from. There is vanilla and cinnamon ice cream to choose from. How many ways can you choose pie a la mode?
All right, so the first choices we're looking at are the pies. How many choices do you have?
4.
And the next is the ice cream. How many choices do we have of ice cream?
2.
Okay, so Wit, how do we figure out how many choices total?
We get 8.
Very good. Any questions? All right. Let's look at number 8. This time they didn't tell you had to do the tree diagram, so that's why there's no reason to. Let's see, Izzy, read it.
Select one fruit and one vegetable.
So how many fruit are there?
3.
And how many veggies do they give you?
3.
So, Izzy, how do I solve this? And you get? So you get 9 total combinations or choices. It's like going to Luby's or, Golden Corral, some of these places where you can just keep going back and choices after choice. How many of you have been to Luby's? Okay, so Luby's is like that, where you go and they say, which salad would you like? Then you move down, which of meats do you want? Which of sides do you want? And you can have many different combinations. All right, let's look at 10. Emily, why don't you read this time?
Select a 2-digit number whose first digit is 0, 1, 2, 3, or 4, and whose second digit is 5, 6, 7, 8, or 9.
Okay, so it's going to be a 2-digit number like our first example. How many choices do you have for a first digit? 5. How about the second digit? So how many possible choices do you have for a 2-digit number here? That's right. 5 times 5 is 25.
Why would you do the tree? Like, I don't understand
Why to even learn it?
Yes.
I have no idea. I can't even tell you why that's even a good idea. That's just a lot of work where this is so much easier. Okay. Let's do 14. Now we're into the B section. You know it's going to get a little bit tougher. Just a little bit. Okay, let's see. Michaela, why don't you read 14?
Choose a number from 1 to 10, inclusive, followed by a flip of a coin.
Ah,
What does it mean by number?
exactly. Okay, a number 1 to 10 inclusive, meaning including all of the numbers. Okay, 1 to 10. So the first is going to be first choice. And it's going to be 1 to 10 inclusive, meaning all of the numbers. So how many total numbers do you have a choice for, Michaela?
10.
Okay, very good. And then the second is a flip of a coin.
We need a point.
You don't need one. How many total choices do you have when you flip any
2.
coin?
2.
Michaela, you have 2. That's right. You have 2 sides of a coin. So how many total choices or outcomes can you have?
20.
That's right. 10 times 2 is 20. Everyone understand? Any questions about that one? All right, let's do 16. Cecilia, read 16.
Flip a coin 3 times in
Succession. That means one after the other. So how many choices are we going to have? I mean, you're flipping it 3 times, right? So we have first flip, second flip, third flip. You're flipping a coin. See, this section makes you actually think. The first couple ones that we did together, pretty obvious. These make you think. Okay, so you're flipping a coin 3 times in succession, right after the other. How many choices do you have on the first flip, Cecilia? In the second flip?
No.
In the third flip?
No.
So, how do I solve this?
2 times 2 times 2 equals 8.
Very good. Any questions about that? Y'all better be writing everything I write down. Because if we finish the examples today and we don't do them tomorrow, by tomorrow, all of this information is going to be cleaned out of your head. So you want to be able to look at your notes and say, oh, I remember now. So write down, don't just write 2 times 2 times 2. You better write everything down that I am. All right, let's look at 18. Michael, why don't you read that?
Choose an hour during the week for an event that can occur during any hour of the day, any day of the week.
Oh my. Read that again.
Choose an hour during the week for an event that can occur during any hour of the day, any day of the week.
Any hour of the day, any day of the week. That's what I'm saying. These things start getting harder and you're like, what is it even asking me, right? So your first choice, it says any hour of the day. How many hours are there in a day?
24.
Michael?
24. Well, there's actually 23.
What?
And 57 minutes.
Okay, whatever.
Wait,
All right,
what?
your second choice, how many days are there in a week?
7.
How do I solve this problem?
Multiply 7 times 24.
Save on time, I'll tell you get 168 choices. Because it can be any hour of the day, like 1 o'clock on Tuesday, 1 o'clock on Wednesday, 1 o'clock on Thursday. See what I'm talking about?
Are they, by event, do they mean the cold freeze that happened?
The what?
No.
It says an event that can happen any hour of the day, any time of the week. So I said, are they talking about the cold freeze that happened?
No. All right, number 20. All right, let's see. Who hadn't had a turn? Joanne, why don't you read?
There are 10 names in the hat. How many ways are there to draw 3 names for first, second, and third prizes from the hat? Assume each person can win only 1 prize.
Okay, now this is interesting. Okay, so we're looking for, there are 10 names in a hat. That'd be like all of y'all. I put all, oh, wait. Okay, we're going to continue this probably tomorrow. So it's time to go to class. I'm going to pause this.